Whoa, we're here. Hello there, CodeMaker 4 here. So I still have the register screen up over here. Not sure if you're going to be doing more work on the registers today. They're pretty much done. The only things that we have to do is if we add other stuff, it might have connections with the registers. You know what? Let's just load up the world. Let's start. We have a few things to choose. Mainly you have to choose what we're going to be working on today. So let's take a quick look at the entire spreadsheet. So these are the instructions. We can only start wiring those up once we have most of the components of the computer in place. So we could do the RAM interface, or we could start building the ALU. Whatever. What do you think we should do? UltraCubic says ALU. Guess we'll be building the ALU then. So let's look at all the things our ALU needs to be able to do. So these are all the ALU related instructions, and there's a lot of them. So the ALU has a bunch of features. So I think just like last time, I am going to be making a screenshot of all the things you have to implement, and then just kind of go and implement that. Let's grab a screen snip, and let's just take a photograph of all the instructions we have to do. Like that. Desktop. We're just going to overwrite it. Oh, it overwrites immediately on the stream as well. Good job, developers of OBS. Where's multiplication and division? So after a big think, I've come to the conclusion that it's not necessary to build a multiplication/division module for in the default ALU, because you can do multiplication and division quite efficiently actually with just doing a few shift left, shift right, add, subtract in an efficient way. Perhaps it's a nice programming, a proof of concept program we could make for the computer. So that's why I'm not going to be doing a hardware implementation of division and multiplication. Oh, and I'm just scared. So we need to create an 8-bit ALU. The ALU will have a few inputs and outputs. Actually, no, not even. It's just supposed to output to this bus and take inputs from A and B, because what it does is it essentially does set the ALU mode. So this will also let the ALU do all the calculations immediately, then load the ALU, then wait for the bus to update, and store the value into the A register. So essentially, it's just gonna be the ALU will be outputting into this bus, and then we give a pulse to that gate to make sure that it gets stored into the A register. And the ALU also uses the A and B registers as inputs. So let's just build an ALU, I guess. I think we want to use this. I probably created this for the SMC2. Oh, okay, so I think I know how this was supposed to work. So this one here turns on or off subtract mode. And this one here enables the output. Did I add any description to this? No, I did not. Now you could just look at the ALU. This is the ALU of the SMC2. It's just an entire separate module. As you can see, I did use that thing there. And I just need to remember which one was A and which one was B, because I need to make sure that I hook it up correctly. What? Oh no, I see it now. Yeah, okay, so the B goes to the top and the A goes to the bottom. Actually, yeah, okay. Boom! Add, subtract, done. Actually, I will still have to... How do you say this? So if you just take a look at... so you have an add instruction on the add carry instruction. And essentially what the difference is that one instruction is just a normal 8-bit addition, and the other carry instruction takes the carry from the last instruction or uses it as an input. So essentially, if you wanted to do a 16-bit addition, what you could do is you could load the first 8 bits of both 16-bit numbers into A and B, do an add instruction, store the output somewhere else, then load in the second 2 halves of A and B, do add carry, and essentially this add instruction would take the carry output, remember it, and when you do add carry, you take the carry output from the last add instruction and put it back into the carry input, which means that essentially you're just chaining one long add instruction. You can then just keep doing add carry, add carry, add carry to do a as long as add instruction as you want. So given the like 60,000 bytes of memory there is in the computer, plus some to write some code, you could theoretically do like a, wow, that's like 30,000 times 8. You could do a 42,000 bit instruction. No, 4,200,000, a 2,400,000 bit instruction. A 250,000 bit addition ALU thing. So that's going to be quite powerful, though it will be rarely used, most likely. That's why I have to kind of figure out where does the carry in go in this block of blue. Cubic says you're playing Connection Simulator 2016. Yes. Actually, why am I just doing so difficult about this? You don't have to know what carry means. It's just that the carry is always just connected to the next one. Doesn't get manipulated by if it's in subtract mode or not. So I think you can just you don't have to invert it or anything if it's in subtract mode. You can just like send it back into the carry input. So I think that's the entire carry problem dealt with. But I do want to make a carry input and carry output gate. So let's make the input and output panel before you forget. Did I do that properly? Oh my god, I did. Look how beautiful, all these parallel logic lines. Will I connect memory manually? Current plans are that the 16-bit memory address space, so that's like 65,000 bytes of RAM. That's going to be the only that I'm going to be doing that with modpack, and that you could swap it out for a vanilla version. But I will also release a version that has like I don't know, like 100 or 250 bytes of vanilla memory. But that recommended is that the memory is just the only modpack part of the computer. It's lame that I do that. Well, I mean, if you want to make 65,563 bytes of RAM in Scrap Mechanic without your computer dying, okay, like maybe you could do it with time memory. Okay, maybe I will also release a thing that does the entire address space with timer memory in a smart way that means that it doesn't take 4 hours before you can load the address. Because I did also add to the architecture that the computer can be made to wait for a theoretically arbitrary indefinite amount of time for the RAM to complete an operation. Okay, so I think that this is most of the ALU, of the addition subtraction part of the ALU done. Oh wait, also the entire point to make this input output panel is so that you could also, already get a fixed location for the carry in and carry out. I'm going to be making this the proper colors. Then data in. Least significant bit, sorry.